Unperfect Randomness, How Chance Rules Our Lives, author Leonard Mlodinow. Subtitles by freebooksummary. Introduction. Each of us has at least once felt that supernatural forces have suggested a solution to some problem. Such was the case in the life of a Spaniard who won the jackpot in the National Lottery in 1977. His ticket number ended with the number 48. I dreamt about the number 7 nights in a row. And 7 times 7 would be 48, he said in an interview. A person who remembers the multiplication table even slightly would immediately snicker sarcastically and say that 7 times 7 would be 49. But it is hard to judge the lucky Spaniard. Each of us forms our own vision of the world, through which we pass all our sensations, and sometimes the mistakes we make are just as important as the successes, as in this case. It's worth saying that scientists have long ago realized that intuition is of little use, especially when uncertainty rules the world. Back in the early XX century, researchers noticed that people cannot build a sequence of numbers that would meet the criteria of randomness. In other words, if you were asked to name 10 random numbers, they still wouldn't be. More than one study has shown that if randomness is involved in a situation, a person's thought process will misfire. Probability theory, despite its importance, never made it beyond scientific circles, is virtually unknown to the average person. Physicist Leonard Mlodinow has tried to correct this injustice with his book. Human intuition does not recognize randomness. For every event, the brain looks for a specific cause, and it has difficulty taking random or irrelevant factors into account. Mlodinow's main goal is, through his book, to enable everyone to realize that success or failure is sometimes not the result of outstanding ability or lack thereof, but of random circumstances. Misconceptions about the exceptional importance of individuals is another problem caused by a lack of knowledge of chance. In the world of sports, for example, there is a belief that the victory or defeat of a team depends mostly on the professional qualities of the coach. That is, if a team wins several matches in a row, the coach becomes almost a genius. Conversely, if the team is on a losing streak, the coach is often fired. However, recent studies show that firing coaches has a negligible effect on the nature of the game. If a team has been losing for a long time, it is likely to continue to do so under a new coach. The same is true in the world of large corporations. There is a perception that the CEO of a successful corporation is able to roll mountains and the company has achieved everything just because of him, which is not really the case. Leonard Mlodinow's book will help you understand when randomness becomes the main criterion in everyday life. Chapter 1. How Chance Influences Our Lives. Leonard Mlodinow's father lived during World War II. He lived in the Buchenwald concentration camp for several years. In the book, Mlodinow says that his father does not remember this time, but occasionally tells stories. Prisoners at the camp were hardly fed at all. One day Leonard's father stole a loaf of bread from the bakery. The theft was noticed. All the prisoners were lined up and told that they would be shot one by one until someone confessed to the crime. Mlodinow's father stepped forward to save the others. In telling this story, he didn't try to make himself look like a hero. He would have been shot anyway. Surprisingly, the baker asked to let his father live. Even more, he made him his assistant in the bakery. In the conditions of camp hunger, it was a very good place. Telling this story, Mlodinow's father said, "It was an accident, nothing more. It had nothing to do with you, but if things had turned out differently, you would never have been born into the world." In 2002, the winner of the Nobel Prize in Economics was scientist Daniel Kahneman. Unlike the other nominees for the prize, he wasn't even an economist. Kahneman is a psychologist. He spent several decades studying the theory of randomness and the fallacies associated with it. His immense research work has turned the tide on how chance affects everyday life. It all started back in the 1960s, when Kahneman agreed to give a lecture to Israeli Air Force instructors on how behavior modification affects flight training. The essence of the psychologist's lecture was that there is no point in punishing mistakes, but there is in encouraging them. One of the instructors listening to the lecture disagreed with Kahneman's point. "Often I praised pilots for perfectly executed maneuvers, and what do you think? They did much worse the next time. I yelled at the ones who did the maneuvers poorly. The next day, they did much better. So don't tell me fairy tales that encouragement helps to improve the quality of work, while punishment does not. I know from experience that is not true," the instructor said. Many of those in the room agreed with the instructor's thinking. And that gave Kahneman the impetus for research that has taken him more than 40 years. Kahneman began to reason. There was logic in the instructor's words. But he knew from his observations that more could be accomplished with encouragement than punishment. After a while, the answer to this dilemma came to him. There is a term in math called regression to the mean. Its essence is that in a series of random events, there is always an extraordinary event, one that goes beyond the standard ones. This mechanism applied perfectly to pilots. Every pilot knows how to fly an airplane, some more, some less. In order to become better, it is necessary to devote a large number of hours of training. So a pilot's skill grows, but in the short term, there is little change. Therefore, any to good or to bad flight depends on luck. If a bad pilot lands the airplane perfectly and goes beyond his current level, his next flight will probably be at a more average level. What will the instructor do after that? Of course, he will praise the pilot for the excellent flight. And when the next flight does not meet his expectations, he will decide that the reason for the failure is because of the praise. Now consider another situation. An excellent pilot who has flown hundreds or even thousands of hours makes a mistake. He performs a maneuver poorly, lands, and hears an angry comment from his instructor. Next time, regardless of what the instructor says, he will make a flight that is much closer to his level. The instructor, in turn, will think that the reason for this is because he yelled at him. The instructors who came to Kahneman's lecture were convinced that yelling at a pilot would do him good. In fact, this practice had no effect on the pilot's level of training. After this incident, Kahneman wondered, if intuition fails instructors, surely the same thing happens in other fields: medicine, business, sports, the military, or everyday life. For the next 40 years, Kahneman and his colleague Amos Tversky did a Herculean job of proving that intuition is most often useless and that randomness occupies an important part of our lives. In the 1950s, a major American publisher rejected the book on the grounds that it was too boring. A monotonous narrative of bickering in a typical family. Even if the topic World War II were still relevant, the book would hardly be a success. The publisher responded. Years later, the book, The Diary of Anne Frank, sold 30 million copies. The same rejections were received by George Orwell, Sylvia Plath, and Tony Hillerman. Orwell, for example, was told that stories about animals would not be in demand in America, and they wrote this in response to the manuscript of Animal Farm, which subsequently received 25 printings. That's why business books and articles are peppered with the same advice. Don't give up. There may be a short window of time and wasted effort between a successful novel and a manuscript no one wants, but there can also be rejections from dozens of publishers. The same goes for a successful business, product, or movie. According to Mlodinow, it cannot be said that abilities mean nothing. They greatly increase the chances of success. However, the road to success is not as straight as one would like to think. For humans, random events often look like non-random events. In fact, we're not that far removed from our ancestors, who didn't believe in randomness and identify every event with a higher power. When we consider incredible success, whether in sports or elsewhere, the following must be kept in mind. Unusual events can happen without unusual causes, says Mlodinow. Chapter 2. Cardano's Probabilities. Virtually every American, especially of the older generation, knows the name Marilyn Vos Savant. For decades, the Guinness Book of World Records has listed her as one of the smartest people on the planet. Her intelligence quotient is 228 points. Since 1986, she has been running the column Ask Marilyn in the magazine Parade. The popularity of the column soared to incredible heights in 1990, when Marilyn was sent the following task. You are a contestant on a television quiz show. The presenter asks you to open one of 3 doors. Behind one of them is a car. Behind the other 2 is a goat. You choose one of the doors, and the presenter, who knows where the car is, opens one of the 2 remaining doors. There is a goat. The presenter invites the participant to change their mind and choose the second of the remaining doors. Does it benefit you to change the door? It seems that the task is simple. There are 2 doors left. The participant does not know which one the car is behind, so the probability of the correct choice is 50%. Accordingly, it is pointless to change your decision. However, Marilyn answered in her column, it makes sense to change the door. That answer made both her and her column immortal. The newspaper received thousands of angry letters from ordinary people mathematicians, professors, each of which expressed Marilyn in a way that was, to put it mildly, not very nice. And in order to understand why Marilyn was right and she was right, it is worth studying a little biography of the Italian physician, gambler and philosopher Girolamo Cardano. The most significant event in Cardano's life was not surviving a plague epidemic or serving as a court doctor. It wasn't even his son who turned him into the authorities in order to get a place in the Inquisition. Cardano is best known as the author of a treatise on gambling, the first work in human history to deal with the nature of uncertainty. In this treatise, Cardano discusses the mathematical part of gambling, the characters of players, and the ability to learn. The most interesting is Chapter 14, on common points, in which Cardano derives the law of the space of elementary events. In modern language it sounds like this: a random process has many equally likely outcomes. Some of them are favorable, i.e., lead to a win, while others are unfavorable and lead to a loss. The probability of favorable outcomes is equal to the fraction of unfavorable outcomes, and the set of all outcomes forms the space of elementary events. Even in modern language, the law sounds quite complicated, but it is easy to understand it if we take a plane cube as an example. It has 6 sides and they form the space of elementary events. That is, the total number of possible outcomes. If a player bets that a 1 or a 2 will fall out, his chances of winning, or the probability of a favorable outcome, are 2 out of 6 or 1 out of 3. This sounds obvious now, but in 15th century Italy, Cardano was forced into poverty because he was accused of blasphemy for writing this treatise. We can now return to Marilyn's task. The TV quiz contestant chooses one of 3 doors. He does not know which one is the prize, so his chances of winning are 33% or 1 in 3. After choosing, the presenter opens one of the doors. The car is not there, and offers the contestant to change his choice. The contestant is confused. There is no point in changing it, because nothing has changed. But in fact something has changed. The total number of possible outcomes is no longer 3, but 2. Accordingly, the probability of guessing the door is not 33%, but 50%. The statistics of Monty Hall's TV program, from which this problem is taken, confirms this theory. Those who found themselves in a similar situation and changed their initial decision won about twice as often as those who kept their choice. Chapter 3. The Laws of Large and Small Numbers. In 2009, author Leonard Mlodinow and his friend Moshe met in a dining hall at the University of California. Moshe, unlike Mlodinow, believed that there is no such thing as randomness, and that truly random numbers simply do not exist in nature. Such numbers don't exist in nature, Moshe said. Yes, they write computer programs, make tables, but in fact they deceive themselves. According to Mlodinow, Moshe was an Orthodox Jew and, in his understanding, God could not allow the existence of coincidences. Moshe proposed a theoretical experiment to Mlodinow. Imagine that you throw a dice n times and write down a series of n numbers that fall out. Do you think this is a series of truly random numbers? Moshe asked. It is difficult to answer unequivocally here. On the one hand, under perfect conditions, the numbers will be random. On the other hand, the dice may not be perfect, and some faces may fall out more often. In 1947, scientists at the Rand Corporation decided to assemble a table of random numbers to find approximate solutions to equations. To get these numbers, they decided to use electronic noise and record the frequency values generated by the device. Having created a huge table, the scientists decided to test it. After a series of tests, it turned out that the table had distortions and some numbers occurred more often than others. Just like Moshe's dice, they called the table 1,000,000 random numbers. The name was a bit louder than the actual nature of the table. The fact that randomness is much rarer than we realize was also believed by an Englishman named Joseph Jagger. He worked as a mechanical engineer and knew that even the most perfect mechanism can be imperfect. He decided not only to prove his hypothesis, but also to make money out of it. Jagger traveled to Monte Carlo, hired 6 assistants, and sent them to the 6 largest casinos in the city. Each of them wrote down all the numbers that fell out on a roulette wheel for a week. The theory was that if the roulette was perfectly balanced, the numbers would fall out with equal probability. A week passed and Jagger finished analyzing all the data. It turned out that 5 roulette wheels really didn't have any outliers, that the 6th had several numbers falling out more often than others: 7, 8, 9, 17, 18, 22, 28, 29. Jagger went to this casino and played there until evening. His efforts more than paid off. By the time the casino closed, he had won more than $70,000. By the fourth date, he had already accumulated $300,000, and casino employees were looking for a way to get rid of the lucky player. They realized that something was wrong, but they had no way to prove it. On the fifth day, Jagger started losing. He was betting on the same numbers, but he began to make mistakes much more often. The engineer couldn't figure out what was wrong until he remembered the tiny scratch on the roulette wheel he was playing at. Spending so much time at the same table, he was able to examine the device in great detail. By the fifth day, the scratch was gone, and Jagger realized that the casino managers had changed the wheels. He walked around the casino building and found the very same roulette wheel. On this day, his winnings had already reached $500,000. The casino staff realized that Jagger's luck depended on this wheel and began changing the numbers. On the roulette every few games, Jagger started losing again and decided to leave the casino. However, not empty-handed, he took $325,000 with him. In terms of today's exchange rate, this amount is equal to $5 million. Chapter 4. How to determine the probability of errors. For the first time, the need to learn how to identify errors arose at the end of the 16th century. Then astronomy and experimental physics began to develop, and scientists needed new ways to conduct theoretical research. The efforts of scientists were not wasted, and in the same century, new field of science, mathematical statistics, emerged. Now statistical methods are used not only in science, but also in everyday life. They check the effectiveness of medical drugs, the popularity of politicians, the interest of buyers in a new product. Statistical methods are based mainly on finding the average of a certain number of studies. In the Middle Ages was different. Scientists checked their experiments several times, but as a result they took not the average value, but the most suitable for themselves. Moreover, it was considered a sign of incompetence to indicate several different values in the results of studies. One of the first to suggest that different types of measurements are characterized by the same errors and mistakes was Daniel Bernoulli. This concept was later given a name: the law of random error distribution. The mathematical function that describes the law is called a bell-shaped curve. Normal distribution, Gaussian curve. On a graph, this function looks like a bell. It denotes the following: if a certain number of measurements are taken, most of the results will be adjacent to the mean and will gather at the peak of the bell. The more the result differs from the average value, the more rare it is and therefore farther away from the peak. The whole set of these results will form a bell-like pattern on the graph. An unacceptable margin of error in statistics is considered to be 5% and above. When a research agency reports the results of a survey to the media, they specify that the margin of error is plus 5%. This means that if the survey is repeated n times in a row, the result will be within 5% of the true value of the calculated quantity. The size of the margin of error also depends on the sample. An acceptable percentage for a sample of 100, 0 people will not be correct for a sample of 10,000, 1, 0, 100 people, and so on. Chapter 5. Mathematical chaos. Statistics has often wrecked people's fates. In the 1960s, French-born Jean Comment needed money. She entered into a contract with a lawyer who had recently turned 45 years old. According to the contract, the lawyer was obliged to pay Comment a small monthly allowance. She, in turn, bequeathed her apartment to him upon her death. For the lawyer, the conditions were excellent. Comment had recently turned 90 years old. That is, the old lady lived 10 years more than the average life expectancy in France. This information the lawyer knew. However, he did not know another thing, that it is not so important the average life expectancy if a person is already 90 years old. What is more important is that, based on the 90 years lived, the average life expectancy increases by 6 years every 10 years. After 10 years, the lawyer must have gotten desperate and looked for another place to live, because Jean Comment had celebrated her 100th birthday and was feeling pretty good. Then another 10 years passed and an unpleasant thing happened. Comment turned 110 and the lawyer whose money she was living on died at the age of 67. Certainly, is a case outside the standard range, but patterns can be inferred from statistics. When 19th century scientists began to apply statistics to analyze everyday life, they discovered that seemingly immeasurable quantities were actually not as chaotic as they seemed. In the Middle Ages, Using statistics to measure data about people was considered unworthy. Disease, its effect on life and death were all considered to be measured from above. And trying to influence or analyze a divine decision was blasphemy. It made no difference whether a person died of pneumonia, the plague, or a robber's knife in a back alley. Fatalism was at the top of the list. However, over time, statistics began to be applied in all sciences and spheres of activity. For example, in 1840, Charles Darwin's cousin Francis Galton began using it in biology. Being a rich heir, he could not care about money, so he devoted all his free time to observations. He assessed the degree of attractiveness of girls on the streets of different cities, the number of movements that students make in lectures, and distinctive features in fingerprints. His last work found its way to Scotland Yard. In 1901, detectives began using Galton's methodology to catch murderers. Galton also calculated the life expectancy of rulers and church officials of the highest ranks. He found out that their life expectancy does not differ in any way from the life expectancy of other people, which means that prayers do not affect much in this regard. Galton made his first outstanding discovery in 1875. At that time, he gave out bags of pea pods to 7 of his friends. Then his friends returned the seeds from the next harvest. And then Galton noticed that the seeds born from seeds with a small diameter, larger than their parents. Subsequently, Galton conducted a similar experiment, but with humans. The same tendency was there. Children whose fathers and mothers were smaller than others at birth turned out to be taller than their parents. Galton called this phenomenon regression to the mean. By discovering this phenomenon, Galton realized that events that do not fall under regression to the mean sooner or later get out of control. For example, a tall man gives birth to a son who is taller than he is. Then the situation repeats itself over and over again. Finally, after a certain number of generations, a giant is produced. Such mishaps don't happen because of regression to the mean. Therefore, genius parents should not be sure that their child will turn out to be a genius. A golfer who is on the list of the world's best players may well have a mediocre son who is not fond of sports. And so on. Mlodinow believes that there is often logic in random changes, but at the same time, they are not always filled with meaning. It is important to discern the meaning where it is, but it is equally important not to try to extract it from where it is not, writes the author of the book, Chapter 6, The Drunken Man's Walk. A mind which would know, at any given moment, all the forces animating nature and the relative position of all its constituent parts, if in addition it were extensive enough to subject these data to analysis, would embrace in one formula the motions of the greatest bodies of the universe, on a par with the motions of the lightest atoms, wrote the famous physicist Pierre-Simon de Laplace in 1814. Laplace was a determinist, that is, he believed that the future of the universe, science and each individual person can be predicted by state at the current moment. For example, let's take a human being. Each person has a set of qualities, past events, and situations. According to determinists, all this information can be turned into indicators and then calculate and predict the future. Of course, this example looks more like science fiction, but scientists have long since learned how to predict other phenomena. The weather, for example. Edward Lorenz, an American meteorologist, did it for the first time. In the 1960s, he tried to test Laplace's theory and loaded data on atmospheric conditions of pastures into his machine, an elementary analog of a computer. Lorenz expected that the computer would supplement this data with missing information and make the necessary calculations. However, everything went wrong. Lorenz's machine took the data and produced illogical results. It turned out that the computer could store numbers to the 3rd decimal place, and the numbers Lorenz was loading into the machine were to 6 decimal places. Even this minimal error affected the results of the study so badly that they were useless and far from reality. Lorenz was unable to predict the weather, but he discovered a phenomenon called the butterfly effect. According to the definition of the effect, even something as minimal as the flapping of a butterfly's wings can influence the weather situation of the world. The definition seems absurd, like being told that one cigarette smoked in the morning can change your life for better or worse. And yet such events do happen. They are what we attribute to the work of intuition or some higher power. You missed the bus and met your future wife at the bus stop. You didn't show up for lunch at work, and by some miracle you got the contract you've been seeking for the past 6 months. The life of society, unlike science, is not so predictable and is rarely calculable. Mlodinow calls is phenomenon the gait of the drunk. It is a model describing our lives that, despite statistical regularities, still defies prediction. In other words, everything about our lives, work, relationships, and more is highly dependent on chance. According to Mlodinow, people don't notice the influence of chance on their lives because they try their best to see what they want to see. In other words, we measure an actor's success by the size of his talent, a billionaire's fortune by his grip and skills, a popular writer by his incredible abilities. The author of the book advises to learn not to make decisions based on intuition. In his opinion, it is worthwhile to comprehend the qualities of people, consequences and parameters of the situation, and only after acting. Often our clear view of the inevitable is just an illusion. I wrote this book with the firm belief that we are able to reorganize our thinking in the face of uncertainty. Mlodinow writes, when we try to interpret certain events, we often forget about coincidences. But once we understand their nature, life becomes easier. Having genius abilities does not guarantee success, nor does having good looks increase your chances becoming a movie star. It is always worth keeping in mind the other variable in the equation of success and failure, the role of chance. Conclusion: the main message of Leonard Mlodinow's book Not Perfect Randomness is that uncertainty rules the world. Many studies have shown that when randomness is involved in a situation, the human brain misfires. Mlodinow's book builds on decades of research by Daniel Kahneman and his colleague Amos Tversky. The scientists studied how random events affect human life and, more importantly, how people respond to them. Kahneman and Tversky won the Nobel Prize for their work. According to Mlodinow, it's not just years of work and effort that lie between a successful and unsuccessful person. A lot is decided by chance. That's why business books and articles are peppered with the same advice: don't give up. The author of the book writes, among scientists and mathematicians, Girolamo Cardano is especially respected, an Italian physician and philosopher who was one of the first to tackle the nature of uncertainty. His treatise on gambling, despite its inaccuracies and vague wording, essentially gave birth to the theory of probability. In the treatise, Cardano derived the fundamental law of chance, the law of the space of elementary events. It is easy to understand if we take a plane cube as an example. Its 6 sides form the space of elementary events, or the total number of outcomes. Any of the rolled sides is a favorable or unfavorable outcome. If a player bets that a 1 or a 2 will fall out, his chances of winning, or the probability of a favorable outcome, are 2 out of 6 or 1 out of 3. Equally important in determining the possibility of random events is a mathematical function called the bell-shaped curve. It is named so because it forms a bell-like shape on the graph. If you make n number of measurements, most of the results will be adjacent to the average value and will gather at the peak of the bell. The more strongly a result differs from the average value, the rarer it is and therefore farther away from the peak. In 1875, biologist Francis Galton made another important discovery. He discovered a phenomenon called regression to the mean. According to this phenomenon, any event returns to its average value. Any natural events fall under regression to the mean. Otherwise, sooner or later they would get out of control. For example, a tall man gives birth to a son who is taller than him. Then the situation repeats itself again and again. Finally, after a certain number of generations, a giant is produced. Mlodinow writes, Mlodinow's final thought is that we should abandon intuition and start believing in randomness. This is a powerful statement, given that they happen more often than we think, and they can even be measured. Mlodinow believes that it is not only exceptional abilities, connections and genius that lead to success, but also random events. Thank you all for listening to the end. If you liked it, don't forget to rate and subscribe to the channel. You can buy the full version of the book at the link in the description.